For the second question, we have, what is the speed of the crate after it is pulled 7.06 meters? So when we know that after we have this displacement, the change in kinetic energy is what we found from the previous video. And that's going to be equal to, I already forgot, 471.157 joules. Well, the change in kinetic energy is just the kinetic energy final minus kinetic energy initial. If we use the formula for kinetic energy, we'll have that the change in kinetic energy is equal to 1/2 times the mass times the velocity final squared minus 1/2 times the mass times the velocity initial squared. I can factor out the 1/2 times the mass. So I'll have 1/2 mass times velocity final squared minus velocity initial squared. If you remember the given information, we know the mass and the initial velocity. We found the change in kinetic energy. So now this is just algebra. We have to solve for final velocity. Let's get rid of that fraction. And then we have twice the change in kinetic energy is equal to the mass times the difference of the squares. Oops. We divide by the mass. I'm going to use the reflexive property. So I have velocity final squared minus velocity initial squared is equal to twice the change in kinetic energy divided by the mass. We add initial velocity squared both sides. And then to make this shorter, to get rid of this square, I'm going to have to take the square root. So it's going to look like this. I'll do the square root at the end. The velocity final is equal to twice the change in kinetic energy divided by the mass plus initial velocity squared, and all that inside the square root. Just like that. So when I plug in my numbers, I'll get twice this number, which I'm just going to copy. Divided by the mass, that was 10 kilograms. Plus my initial velocity, as per the picture, was 1.66. So 1.66 meters per second. Don't forget to square that one. You take the square root. And then the final velocity is 9.8482 meters per second.